We're ready to start page 10 of the 5.3 notes. So we worked on the last page fractions that, well, 2 pages ago, fractions that had the same denominator. So that was pretty easy. We added or subtracted the numerators, kept the denominator the same. Then on the last page, we learned how to find a common denominator. So given a list of denominators, we learned how to find it. Now, in this section, we're going to learn how to make the common denominator, and then we'll put it all together. So we know how to find it. Now we need to learn, how do I make this look like this? Because this is my common denominator. How do I make that look like that? So you can relate it to a problem like this. Let's say we need this to be ninths. And you'll see the problems look just like it. So in your head you say, 3 times what gives me 9? 3. Whatever I multiply the denominator by, I must also multiply the numerator by. And so I find out an equivalent fraction to 2/3 is 6/9. So I provided the missing factor, which was 3, so I could have a new denominator, which is the LCD. So we're going to be doing that same process, but just now with polynomials. So guess what the first step is? What's been the first step on every problem? Factor. So we need to factor the denominator. So this is a difference of squares. That's if there's not a common factor, which there is not, then we look for squares, and there is. So that factors as x plus 2, x minus 2. So step number 1, factor the denominators, just like all the other problems have said. Factor the denominators. Okay, so now we have this new scenario. So same thing. Here's the first fraction. The second fraction is just now factored the denominator. So I can see, for this to look like this, it's missing x plus 2. So I need to multiply the denominator by x plus 2, like I did here. I'm just putting it on the left instead of the right, just because I didn't have room on the right. But whatever I do to the denominator, remember, I have to do to the numerator as well. So what is this missing to make it 9? 3. What is this missing to make it look like this? X plus 2. And the rule is, whatever you do to the denominator, you must do that exact same thing to the numerator. Does everybody know why you have to do it to both? What's 3 over 3 equal to? 1. When you multiply a fraction by 1, do you change its value? No, you don't. That's why you always have to do the same thing to both numerator and denominator. So although 6/9 looks different than 2/3, when you divide 2 divided by 3, you get 0.6666666. When you get 6 divided by 9, you get 0.6666666. So they're still equivalent. They just look a little different. So by doing the same thing to both the numerator and the denominator on this fraction, I won't change the value. I'll just change the looks so it can have this common denominator. So when I multiply numerator and denominator by x plus 2, I get x squared plus 2x over the common denominator. And you could write x plus 2, x minus 2, or x plus squared minus 4. That's just this FOILed out. So I would prefer you left it like this. So I'm going to write that over here. That's the answer I would want to see, because that's the one that's useful when you go to add and subtract your fractions in the next section. So they just want the numerator in this problem, so you're just going to type that in, but this is the form you would leave it in to add. And they are equivalent because that's just this factored as a difference of squares. Okay, let's practice on a couple and see how we do here. So as I said, step number one, always is factor. So if you're ever going, oh man, I don't know how to start this problem, just do the go-to. The go-to is factor. So I see these can't factor, but this certainly can. It's a trinomial. Looks like it's going to be double bubble. So let's go ahead and bring this down here. So we know it's double bubble because the leading coefficient's 1, and we're looking for factors of 2. There's only one set, 2 and 1. Do they subtract to 1? Yes, they do. And I noticed a lot of people on the last test missed problems because of the signs. You have to check the signs after you put them in. Don't just go, oh yeah, I'm sure they're right. So this says the signs will be different. And this says the largest one needs to be negative. So let's say you made a mistake. All you'd have to do is add these two and see if they give you back. This number is -2 plus 1, -1. Yes, it is. So there's your answer. So x plus 1, x minus 2, I get from that. So now I look at the problem and I say, what is this denominator missing to make it look like this? It's missing x minus 2, right? So binomials need to be in parentheses. So it's missing x minus 2. But remember, just like up here, whatever I do to the denominator, I have to do the same thing to the numerator so that it's really just 1, because multiplying the fraction by 1 will not change its value. So then we get 5x squared minus 10x. And there we have it. So this fraction is equivalent to the original. I just had to multiply it by 1 in disguise. X minus 2 over x minus 2 is still 1, but now it has the denominator that I need to add it to other fractions. And remember, that's the same thing as this. 5x squared minus 10x over, when we FOIL, we get back to that, x squared minus x minus 2. So I think this is how Alex wants you to write it. Okay, so FOIL that, you get that. Minus 2x plus 1x is minus 1x, and then minus 2. Okay, next one. So this one, we need to multiply this fraction by something. So let's leave a little bit of room to make it look like this one. So first we have to factor. Step number 1, always. Factors of 15 that subtract to 2 are 5 and 3. Signs are different. Largest number in the pair needs to be negative on this one. So we turn that into x minus 5 and x plus 3. And just pause a second, make sure your signs are right. Is -5 plus 3 -2? Yes. So then I say, what is this fraction missing to make it have that common denominator? Oh, it's missing x plus 3. So whatever I multiply the denominator by to give it that common denominator, I must multiply the numerator by. So do you see how we're doing exactly the same thing we did here? What is it missing to make it 9? It's missing 3. Do the same thing to the denominator and numerator, then multiply to get your new numerator. Same exact thing. So this one is going to be a FOIL problem, I hope you notice, because it's 2 terms by 2 terms. So we get x squared plus 3x from the outer, minus 1x from the inner, and minus 3. And then simplified, let's go ahead and put the answer up there. Simplified, that would be x squared. 3 minus 1 is positive 2x minus 3. And that would be my answer. So that's the numerator I need to have a common denominator. Or we could write it as x squared plus 2x minus 3 over the common denominator. So they're both exactly the same thing. This is the denominator factored. This is the denominator not factored. Okay, a couple more to practice on. Now would be a good time to turn off the camera. You have about 3.5 minutes left on the time, so turn it off and go ahead and work those two, and then turn it back on and we'll check our answers. So this one is x over x minus 1, and we need to multiply it by something to make it. Factors of 7 that subtract a 6 are 1 and 7. This says make the largest plus, and then ask ourselves, is 7 minus 1 positive 6? Yes. So check your signs. You don't want to miss an entire problem just because you missed a sign. So all you have to do is add or subtract those and make sure you get that. So now I ask myself, what is this problem missing to make it look like this? It's missing x plus 7. So if I multiply the denominator by x plus 7, I must multiply the numerator by x plus 7. And that gives me a new numerator of x squared plus 7x above my common denominator. So I can either write it like this, or I can put it here with the original fraction. They're the same because this is just the factored form of that. I think all they want you to type in on Alex is just the numerator. So that's not so bad, right? Okay, next we have 1x and 2 x's. So what am I missing? I'm missing an x on the x. Well, here, let's write it bigger just to make it easier. So 6x to the first, y to the third, z to the second. And I need it to look like x2, y3, z5. Okay, so how many x's are missing? I have 1 and I need 1 more, right? So let's multiply it by 1 more x. Here I have 3 y's and I need 3 y's, so I'm not missing any y's. Here I have 2 z's, but I need 5 z's, so that means I'm missing 3 z's. So this is going to give me 2 x's, 3 y's, and 5 z's. Boom! But whatever I do to the denominator, I must do to the numerator. So I put that up there, and what's my new numerator? 6xz cubed. And there we have it. Pretty fun stuff, huh? Okay, we just have 20 seconds, so we'll stop here and start the next page on the next video.